Hey guys, I'm just going to go over one last topic really quickly regarding measures of center when we're talking about ways that we describe these graphs. So, excuse me, yesterday, if you remember, we talked about shape and all of the things that we need to address when we're talking about shape. So, symmetry, number of peaks, things like that. Measures of center is something else that we're going to need to talk about when we're describing graphs. So we're going to go ahead and just kind of briefly talk about that. So the big idea with measures of center is that there's three different measures that you can use, but it depends on what type of graph you have, and specifically it depends on the shape of graph that you have. So for example, let's start with the normal distribution. Okay, this is what we would call symmetric, right? And it has only one distinguishable peak. Okay, now in this case, the mode, the median, and the mean are all going to be very good measures of center because it's a normal distribution. So basically you can't go wrong when it's normal or bell-shaped or perfectly symmetric like this. So you might be asking yourself, what's the difference between the mean, the median, and the mode? So obviously you know what those mean in terms of calculation. The mean is the average, the median is the middle value, and the mode is the one that occurs the most frequently. So for this purpose though, we want to take a look at how the shape of the graph can actually affect each of these. So let's start with the mode. First of all, the mode is just the most commonly occurring number, or the most frequently occurring number in our data set. Okay, so regardless of whether or not our graph is skewed, as you can see from the examples here, the mode is not going to change. It's always going to be at the peak or peaks, depending on how many our graph has. So the mode is really not going to be a good measure of center unless it's like we have here, a normal distribution in the center. And the reason for that is because the mode is always going to be at the peak, but the central tendency of the graph may not be at the peak. For example, we saw some graphs in the past where we had like a peak over here and then another peak over here, right? So we would have, potentially, we could have a mode occurring at both places, okay? But neither of these places represents the exact center of our graph, okay? So the mode is really not going to be a good measure of center unless it's a normal distribution, okay? So then let's talk about the median. Now the median, if you remember, is just the middle value. If we line up all of our data in ascending order, it's just the exact middle value. Okay, now the nice thing about that is that no outliers or extreme values are going to affect our median. Okay, so the nice thing about the median is that it doesn't really matter what our data or what our values are numerically. We can have numbers from 0 to 100. We can have numbers from 0 to 100 million. It doesn't really matter. If all we have are 19 pieces of data, our median stays the same. Okay, so if you'll notice on all three of these graphs here, the median is actually the best measure of center for each one of these graphs. And the reason is because the median is not affected by any of those extreme values that we might have like out here or extremely low values down here, okay? Versus with the mean, obviously the mean is something that's calculated based on the data values themselves, not how many there are, but what their actual worth is. So for example, if we have a lot of our data, you know, in the high numbers, but then let's say we have one really low number that's really pulling our data down, our mean is going to get pulled in the direction of that really low number. Okay, same thing on the opposite end. If we have just a few, maybe even one really high value up here, so that could be an outlier, it's going to drag our mean way out there. Okay, which now means that the mean is not going to be a good measure of our center because he's being pulled so hard in that one direction, or in this case he's being pulled to the left. Okay, so kind of the moral of the story is that if it's a normal distribution, really any of them are going to work, the mode, the median, the mean. However, if it's a skewed distribution or non-symmetric in any way, really the median is going to be your safest bet as far as measuring the center of the graph. Okay, so let's take a look at some examples. So this is an example, just some arbitrary data that I found on the internet. So if you take all these numbers and you find the median value, so there's 41 pieces of data here, divide that by 2 to find where the median is located. So the median would be located at the 20.5 piece of data. Well, since we don't have 0.5 pieces of data, it's going to occur between the 20th and the 21st piece, which is right about here, up at 2. So that means that we're going to have a median for this set of data of 2. Okay. Now, on the other hand, if you take all these numbers, you add them up and you divide by the number of pieces, you're going to get a mean of about 2.9. Okay. Which 2.9 is just a little bit off. That puts us right about here. Okay. So as you can see, these upper numbers here, even though they're not outliers, 7, 8, and 9, those are definitely not outliers. They're perfectly fine pieces of data. But again, they're much higher than 1 and 2 and 0 like what we have down here. So these high numbers are really pulling your graph toward the right-hand side there. So that's why your mean is shifted to the right of the median, and it's not going to be as good of a measure of center just because it's being affected by these upper numbers up here. Okay, so again, you can kind of see the shape of this graph. It's skewed to the right there. So again, since it's skewed, you should automatically know that the median is going to be your best measure of center. And again, that's just because the median is not affected by any extreme values on either end. Okay, so let's take a look at another example. So this one's a little bit tricky because you have a gap here between, it looks like 72 and 80. All right, so if you kind of look at the overall shape of this graph, you can clearly see that there's 2 peaks. We've got 2 kind of clusters of numbers going on. We also have a gap. We may have some outliers. It doesn't look like we do. So if you take a look here, there are 20 individual scores. Okay. Now, if we determine the median of those scores, it actually ends up being 80%. So this 80% right here is the, is the median. Okay. Now, if you take the mean or the average of all these scores, you actually get 82, which is not that far off. And there's a couple reasons for that. So even though this graph is not perfectly symmetrical, right? So not exactly symmetrical. Okay, it's not exactly symmetrical. There are portions of it that are symmetrical enough, we can say. So if you can see here, even though these 2 clusters of scores don't really look exactly the same, they're not mirror images of each other, they're very similar in the way that they're clustered. Okay, which means that they're going to be pulling on the mean equally, right, on both sides. So that's why you're not going to see a lot of deviation here between the mean and the median. Because even though we have some high values up here on the right and some low values on the left, because we have approximately equal number of values and equal worth on each side, it's going to pull on that mean equally. All right, which means that the mean is not really going to get pulled very far from the median. So here was our median. Here's our mean. Okay, so this is a more extreme example. Typically, we won't go over stuff like this because it's very rare for a problem like this to appear on the AP exam in terms of measures of center. But it's a good thing to talk about because I know you guys are probably wondering in your heads, like, oh, what about this extreme example? Okay, so just keep this kind of in the back of your mind. But again, the real big idea here is the mean versus the median versus the mode. Really, you're just looking for whether or not your graph is skewed or if it's symmetric or normal. Okay, so just kind of remember, if it's symmetric, the mean or the median are going to be good judges. Probably the mean is going to be the easiest. But if there's any kind of skewness left or right, any variation in this graph, the median is really going to give you your best guess there. And then the mode, obviously, the mode is just always going to be at the peak. And there's really no way to tell if the peak is the exact middle of the data, especially when we have situations like this going on up here. So typically in this class, we're never going to use the mode, but it was good to just kind of talk about the differences between those things. Okay, so go ahead, and there's an activity for you guys today. You're going to just fill out the portion of the worksheet that talks about the shape and the measure of center. Don't worry about the column that says spread or measures of spread, because we're going to get into that starting next week. Okay, so I wish you guys the very best of luck, and if you have any issues, please don't hesitate to post on Schoology or email me personally. Okay, thanks guys, good luck.